Okay, a couple things to start with. So this is old page, old page. I didn't download it. Let's go. So uh, these are our TAs, and listed alphabetically. Amar will hold a survival help session Friday night starting at 5 o'clock in this room. It's just for people who are struggling. I've asked him if people start asking sophisticated questions, refer them to me. I don't want people that know a lot asking complicated questions while the people who are struggling get blown away. They don't know what's going on. This Friday evening help session is for people who are, struggling to catch up. So if you fall in that category, please attend. Okay. The other three guys right now, they will all be in this room from 5 to 7 on Tuesday night. Okay. I don't know that they'll be here tonight. I hope they will, but I forgot to send them an email asking them to be. Okay. So, but certainly starting next week they will. Now, one of them I may move to another time. Can everybody make Tuesday night at 5 o'clock in this room? Is there anybody who can't make it? Okay, looks like it's probably going to be okay. So one of them may move. But anyway, the model is that, there's 2 or 3 of them here. And, if there's a bunch of people, it just, a nice communal knowledge fest. Okay, so. All right. Also, one other thing, if we go back to the page, there is Haozong generated a little demo for updating the SDK version for your machine. Friday morning, if you were here, I compiled my prototype and it failed because the SDK version on my laptop is older than the SDK version that I use on my main machine at home and where I built the prototype. And so it failed and I had to go and each project I updated, just to use the latest SDK that was on that machine, and then it worked. But instead of doing that, you can open the installer and install the later SDK, and that's what Hao's demo does. It shows you how to open it, and so if you get one of those messages that says that it fails to compile and there's a problem with the SDK, you can open the installer and just get the latest SDK for your machine. Simple. It's about a 2-step process, really easy, and I'll show you how to do that here. Okay, so the agenda today is the main topic is encapsulation, but we're going to do that very briefly. I want to talk about stuff related to Project 1, mostly. We're going to talk about XML. We're going to talk about the XML processor. And I will be talking about that in the Friday morning help session as well. If you come to the Friday morning help session, do not bring chairs from another room into this room. A, that violates the fire regulations. B, last week, Dr. Gershoy had a meeting in 287, and he went to his meeting and there were no chairs. He had to reschedule his meeting. He was very gracious about it. If it was me, I would have been angry. Okay, so don't do that. If there aren't seats available, just come back at 10:30. I promise you, I will be here. You know, what happens is I'll service the first wave from 9 till 10:30. I will kick them out, and then you can, you know. So if you come here and there aren't chairs, don't bring them from some other room. Okay, so first of all, I want to talk about some terms that we're going to use this morning. So encapsulation means restricting access to a class or some kind of entity to a class's state so that only member functions of that class can access that state. And that way, that guarantees that the state, if the class is properly designed, is always in a valid, the state is always valid. The state data is always in a valid condition. Because only the member functions can change it. If you make it public, somebody else can come along and do all kinds of crazy things to the data, and now it's invalid, and the member functions do totally wrong things because the data is invalid. So you want to keep data private almost always, and we'll talk a little bit about that this morning. Not a lot. I want to define some terms that we've been using. So some of this is in response to a Piazza Post student was saying, I'm getting totally lost. You're clicking on so many links, I can't follow. You know, I don't understand the terms you're using. You're clicking on so many links. You're going so fast. You're leaving me in the dust. Okay, so I'm trying to define each of the terms I'm using. You're welcome to stop me if I go too fast. But I have also, one of the students' complaints was that there were so many links, they didn't know which ones I clicked on, and they were totally blown away. You've got so many links on your site. So what I've done is I've marked in yellow the links we're going to use today. There's other links, they're useful, you know, but the most important ones are the ones that are in these yellow. That's what we're going to look at today. So SQL stands for Structured Query Language, and it's a formal language for extracting information from a database and is used with relational databases. SQL database, a database structure with tables, and I should say, and relationships. Each record in the table is uniquely identified by a primary key, usually an integer, and tables are linked using foreign key relationships. It means that if this record in my table needs information from another table, it includes the key. The primary key for that table is a foreign key in this table, so it uses that foreign key to identify that piece of information in the other table that's linked. That's what relational databases do, and SQL sorts all that out. We're not doing that. But we're going to do something kind of similar. So information is extracted using SQL. No SQL database, usually a key value store that identifies each value stored by its unique key. Voila, that's what we're doing. What the prototype does. It may have hierarchical relationships defined by key collections. Voila. That's what our child relationships are. Okay. I had the question in the class, 8 o'clock class, somebody said, can you give me an example? You know, what's this relation? Well, what's all this about? So if we're using this database in a repository, which we will, record describes a file. So if file A in the repository depends on file B and file C, then in file A's child collection, you'll find the key for file B and the key for file C. So those relationships are dependency relationships. So this file, the file described by this key, depends on the files described by those child keys. Query, the extraction of records from a database that matches a specific set of conditions. Often a query may be made on a subset of records from the database defined by a previous query. Now, structured query language is all about making queries in relational databases. We're not going to try to reinvent SQL for our database. You can't do it. SQL depends on the formalism of the relational model to work, and we don't have the formalism of the relational model. So, but we're going to do something similar. So we would need to extract records from the database, and what that means is I'm going to get, when I find something, I'm going to get the keys for the records that match. So if I'm looking, so I make a query, give me, I want to know all the records whose author, first letter of the author's name is F. Or maybe the first three letters are FAW. Okay? So then I would get back the keys for each record in which I'm the author. Now, I might want to make I might want to know not just the files that for which I'm the author, but I want to just get the files for which I'm the author that I've submitted this week. So now I want to, out of that collection of my files, I want to query for those that were submitted this week. So I'll make a query on the keys that were returned by the first query. So a query typically starts with a key set and returns a key set. The first query starts with all the keys in the database. Persistence, the act of saving database contents to a file, usually binary or encoded in XML or JSON. We will use XML. And the operation should be reversible, adding elements to the database from an encoded file. So if I create an empty database when I'm starting up the repository, for example, the database is empty, and now it needs to go and read all those XML files to load up all the records that describe data in the repository. Sharding, the act of saving a subset of the records of a database to a file. So we will demand that our payloads have a collection called categories. So my payload will be a string, the path to a file. So the key will be a file name. The payload is the path to that file, but the payload also contains a vector of categories. So category might be, this is display, or this is user interface. But it also might be threading or sockets. So it may well be that one file belongs to two categories. This belongs to the communication category, and it belongs to the socket category, and it belongs to the threading category. So while we may have subdirectories in our repository to store different kinds of files, we can't use those subdirectories to define categories unless we duplicate the files all over the place, and we don't want to do that. So that's what, sharding, I might say, I want to save all the display files to this, I want to save all the display records to this display.xml. I don't want to save all the UI records to UI.xml. Now, if I'm on the display, working on the display, and I start up the repository, I only want to look at the display files, maybe, and so I'll just load from that shard. I won't load up the whole database. For our projects, it won't be the database won't be big enough that it matters. It doesn't matter. Who cares? Just load the whole thing. But if there's 10,000 records in the database, which a real one may very well have, if you don't shard, you're going to sit there and wait 2 minutes before anything happens while it loads all those 10,000 records. Or sometimes. It might not be 2 minutes, but sometimes. Annoyingly long time. Okay. Okay, now I also want to just make a couple of quick comments about language types. You'll see why in a minute, just bear with me. So imperative languages are languages that command things, command your program to do specific things. Do this, do this, do this, do this. And examples are C, C++, Java, C#. They're all imperative languages. Object-oriented languages are languages that use classes and class relationships to structure programs, but they typically are imperative programs too. So object-oriented programs are languages are typically a subset of the imperative languages. Because they say, do this, do this, do this. Functional languages, language statements define functions and execute them. The whole program is a function. It calls other functions. It calls other functions. And functions are first-class objects. A function can be passed to another function, can be returned by the function. And very often, they operate on immutable data. So I define some data, and now if I want to change it, what I do is I create a new set of data. If I want to add some data, then instead of adding it to that data, I create a new set of data from the old, adding the new stuff. And that typically is done with recursive style programming. It's a very different style than we typically use. Examples are Haskell, Lisp, parts of JavaScript work that way. But when we talk about functors and lambdas are first-class functions. I can pass a lambda to another function or another lambda. I can return them. And I'm going to talk very briefly about that. Declarative language statements declare the desired results, often in terms of conditions, don't specify how those results are achieved. So imperative languages tell exactly how it's going to be done. Do this and this and this and this. A declarative language just says, give me this. Here's what I want. You go figure out how to give it to me. And that's what SQL does. SQL says select where. And we want to do something like that. Not going to be SQL, but you can imagine in our query module, so we create a package that holds as a data member a reference to the database, and it has a function select. And we want to call select display category. And display category is really a callable object, a function, or a lambda that pulls stuff out, does the search over those keys. Okay, so so we want to develop a simple declarative language for getting information out of our database. Not SQL, but kind of the same spirit. Wouldn't hurt to have a select function. Okay. Anybody who's done database, relational database uh, uh, processing is smiling right now, okay? But you're used to that. So that's kind of where we're going. So examples of declarative languages are SQL. Regular expressions are declarative. Prolog is a language that starts out with a set of relationships and it makes deductions about those relationships. Logic programming. Okay, so over the next couple of weeks in the help sessions, I'm going to be talking about queries and persistence. I don't want to tell you too much. I've already given you a lot of help, but I want to give you enough so that there's a path, for you to follow. My goal is to give you a path to follow without putting a little yellow footprint on the rug each step of the way, okay? So that's what I'm going to try to do. We're going to start that this morning. But first, we're going to talk about encapsulation. So, I'm talking here about an information cluster, and I use that term because this idea applies to things more than just classes. It applies to classes, but it also applies to modules, which may be collections of multiple classes. It even applies to programs. So the idea is this, that this entity, whatever it is, a class or a package or a module is a collection of 2 or 3 packages, provides a set of public functions that are simple, well-named, so they describe what's going to happen when you invoke them, and they don't require design knowledge. For example, I don't want to pass them pointers or return pointers. Suppose I return pointer from a function. The caller now needs to know, when I'm done, do I call delete on this pointer or not? If I should and don't, I'll have a memory leak. If I shouldn't and do, I'll have an exception. That means I have to know the design of that entity. So we don't want to return pointers or pass pointers. However, down here inside in these private functions may well require design knowledge. They're happy to accept and return pointers, if that makes sense. Because the public doesn't need to handle them. They don't have to ask those questions. But down here, it's just your public functions that are using these private functions, and they know the design, because they're written by the designer. So the model is that I have private functions are ones that require design knowledge to use. Private data is just data. Now, I don't want anybody else I want only my functions, my public and private functions to manipulate, so that I can guarantee the validity of that data. And that's the whole idea. Now, with classes, it's pretty straightforward. We put the public functions in the public interface of the class. We put the private functions in the private interface. So the public interface, we say public : functions, and then private : public : functions, and then private : functions, and all those below the private are, guess what, private. They're not accessible by clients of the class. You can do the same thing with modules, and I owe you a demo for that. I don't think I have a really good demo. It's used a lot, but I don't think I have a demo for it. I've asked one of my TAs to remind me with an email, and I will probably this weekend do a little demo, and we'll talk about it sometime real soon. Or I just may post it and say, go look at it. Okay, so all these words essentially say that. And again, the reason this was called an information cluster is it applies to more than just classes. Encapsulation is important for C programs that don't have classes. Now, I'll show you how all that happens. I'll do a little demo, but that's a story for another. There's an encapsulation presentation that I'm not going to walk you through. It talks about quite a bit, more stuff. You go take a look at it. It's fairly straightforward, easy to do. I want to focus on XML because you got to get ready to do the persistence. You need to know a little bit about how you manage that. So I invite you to go look at this encapsulation presentation, read it, and ask questions about it in class on Thursday or whatever. I'm kind of constrained here a little bit. On Thursday, I'm going to begin talking about abstract data types. It's a really, really important topic for this course. I'm going to do that on Thursday and the next Tuesday. By the time you're done, you will know an awful lot about the structure of classes. Almost everything you need to know about the structure of classes. So it's important that we get that done quickly. I need to talk to you about XML and persistence, and unfortunately that couples into things like lambdas and functors that I haven't talked about. I will soon. Okay, I'll do a little bit today, but unfortunately C++ is big enough that, especially at the beginning, it's hard to talk about anything without using some terms that we haven't talked about yet. Okay. I hear your pain. So let's talk about XML. Let's start out with a lecture note. So this is a lecture note. This is actually a not quite complete example. In the presentation is a complete example, but this will give you the idea. The main part of XML is markup, and there's always one root. XML, the markup in XML is as a single root. It's a tree, not a forest. Single root. So, and this root here is lecture note. There's an opening tag and a closing tag. The closing tag is, tag is lecture note, / lecture note is the closing tag. And an element, so a tag, stuff in the middle, and closing tag we refer to as an element. That's an XML element. An element, here's a simple element. Here's a tag, title, closing tag, and just some text in between. But clearly, notice lecture note has a lot of markup in its element. You can have either text or markup in the body of an element. So tag, body, closing tag. I'm doing that from my point of view. From your view, it's tag, body, closing tag. Okay. So, and the body can be just text, or it can be another element, or it can be both text and element. Here is a tag. Here is an element that has both text and markup. So Bjorn-Strauss strip is the text, and note is a child element. So this is a text node and an element node. A tag can have attributes. So this tag has lecture note, course equals CSE 687. You can have 0 or more attributes in a tag, in an element, and they have a name, attribute name and an attribute value. The attribute name is not quoted. The attribute value is quoted. They're separated by an equal sign with no spaces. Some of the XML preprocessor will choke if there's a space between the equal sign and the name and the value. Now, for us, this might be database. Record, 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 record. Don't say record 1, record 2, record 3, record 4. If you want all the records in the database, if you just name them record, I can say, give me all the records, bang, there they are. If you make them record 1, record 2, you're going to say, give me record 1, give me record 2, give me record 3, give me record 4. So don't do that. So it's database, record, 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 record. Now a record has a key and a value. So record tag, a record element, key element, key, text name, slash key. The value now has structure itself. So here's value, and then under value is name, date, children, and then children has key, 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 key. You don't have to remember that. The particular format isn't important, but that's the way you do it. So, you want to change the order or, modify that structure, that's up to you, that's fine. Because only your code has to read your, we're not going to take somebody else's code and try to make it read your XML. We're not going to bring our own XML and make you read it. You're going to read your own XML. We may change your XML. So here's something we might do. Here you have your XML and you run it. It runs beautifully, and so we'll come in and we'll remove the closing tag. Okay. What happens? So we probably won't do that because we won't have time. We don't have enough. So that's the model. Now let's talk about the specifics. When that is processed, it typically I don't know why this does such a lousy job of presenting this. The projector down in LSB did a pretty good job of showing all these lines, but these are so faint you can hardly see them. Can you guys see that? Is that okay? So what I had in that text was lecture note down, but there's typically other stuff. There's stuff that comes, so this is the root of the XML, lecture note, or whatever. And the stuff that comes before it is called a prologue, and there can be stuff after it, like another comment, for example, epilogue. I have never written an XML file with an epilogue. I have never seen an XML file other than a little demo that I did. So I lied. I did do a demo with a comment epilogue, but typically prologues are what you see. Now, this is a declaration. This says to the XML processor, I promise you I am a well-formed XML. You may not keep the promise. You should. Your intent is to keep it. And you can have one or more, any number of comments you want, and then the lecture note. But all of this has to get tied together, held together for the processor, and that's typically done with a document node. So when you create a document, that node exists, but it doesn't have anything below it. And then you start adding stuff to the document. You add a declaration, you add a comment, you add, you might add a lecture note, and then to the lecture note, once you've added the document, I can add stuff to the lecture note element, and it'll all be, it's all chained together. So notice that here's my author. An author has both text and a note. I showed you that in text, okay? So an element can have both a text node and a markup. And text is represented by a node, and sometimes you need to know that by a text node. Okay. Notice I have two titles here, title and title. So there's a title for the lecture note, but this reference points to a book. And so that book has a title. So I have two, and that's perfectly acceptable. You know, it's not badly formed XML because I have the same tag at different levels. They just mean different things. Okay. Perfectly okay. And not all XML processors generate this parse tree, but the more sophisticated ones do. I have an XML processor called XML Document that does this. I'm going to run it for you today. And it's structured just like, it builds this tree in memory, and it looks just like this. So now XML has, let's go to the PowerPoint. A little easier for me to show. By the way, some of these, I put these here, these are for me. The some, like the Visio links, the college server won't serve them up. The college server has a white list of extensions that it will serve, and there's ones that won't. C# it won't serve. The model is that C# may describe the code for an application, and making that visible to the outside world provides an avenue of attack to that application. So it's a security problem, so they won't serve up C#, but they serve up C++ just fine. Okay. God bless them. But anyway, XPath and XSLT are languages that relate to XML. They're in the XML family. XPath is a means of navigating, a language to navigate XML documents. So XML is a tree. Directory structures are a tree. We already have a language for navigating directories, slash this, slash that. That's what XPath does. Gives that slash language for XML. I haven't implemented it with my processor, but XSLT is a functional language, a strange, quirky little functional language that is often used to turn XML into other things. One use is to turn it into a web page, styled web page. I used to use that for pages on my website. I don't do that anymore. Turned out to be kind of clumsy. Didn't like that. So it's also used to generate code. You could build an XML that described the elements. So let's say you're building a code wizard, a wizard to create a class and some empty methods and stuff like that. I could describe that in XML and use XSLT to turn that into C++ or C# code or Java. Kind of things that XSLT is used. I'm not going to talk about either XPath or XSLT. I say a little bit about it in these slides, and you're welcome to go look at it. So XML is extensible markup language. XPath and XSLT these are the words I just said. So let's go on. So XML is a tag markup language designed to describe data. And for some reason, this link doesn't work. So I won't click on it, but it takes you to something very like the lecture note. XML only has a couple of predefined tags. The the XML declaration starts with the XML tag, question mark XML, or XML, question mark XML. So, but all the rest aren't defined. So XML is commonly used to define data structures, messages, and create web pages, but also it can be used to create languages. So, for example, there's a consortium of companies that in this country that build medical information systems, the kind of things that your doctor's office uses to keep appointments and keep your medical records and stuff like that. And they wanted to be able to intercommunicate. So my doctor wants to refer me to a specialist, and so he's got to send my information to a specialist. He's using Epic, and the specialist is using some other medical information system. Okay, and so how do they interoperate? Well, the answer is that this consortium got together and used XML to define a language for specifying medical information. And those are validated with something called a schema. The schema says this document is a valid medical information document or it is not. If I link to a schema on an XML page and I process it with a smart processor, the processor will test the schema, and if it doesn't match, it'll stop and give you an error message instead of processing it. My XML processor isn't smart enough to do that. I could have, but I wanted to build that XML processor in 2 weeks, not 6 months. Okay. What it would have taken to validate XML and validate against schemas. There's two methods. There's schemas and there's DTDs, document type definitions. Do exactly the same thing, but they're two different languages. The schema is written in XML. DTD is written in a quirky little language that is not XML. And the reason for DTD's existence is when HTML was invented in 1990 or 1989, whenever it was that Tim Berners-Lee invented HTML, XML didn't exist. And so they invented this quirky little language that are called DTDs, document type definition. And HTML is defined, HTML5 is defined in terms of a DTD. When you say doc type at the beginning of an HTML page, that refers to a DTD. So, most people outside of HTML use schemas to validate documents. I'm not going to talk a lot about schemas. A schema says you're allowed to use these tags, and this tag has to be followed by those tags, or or optionally, blah 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 blah. It's that kind of stuff. So validation said, so to be correct XML, set of markup needs only to be well formed to, so XML, there's two kinds of well-formedness. There's well-formedness of the XML markup. That means it satisfies some syntax relationships we're going to talk about quickly this morning. The other form is that this XML document satisfies a schema. So the XML fragment has to be syntactically correct. The document has to match a schema if you provided that link to a schema. So two notions of well-formedness. I'm going to talk about the first. And I say, hey, it uses document type definitions, DTDs, or schemas. Here comes some of the syntax. So XML element have a tag, star means 0 or more. 0 or more attributes where you have an unquoted name, equal sign, no space, quoted value, no space, and you can have multiple ones, and they are separated by spaces. So I can have an attribute space, attribute space, attribute, where the individual attribute is name, no space, equal, no space, value, quoted value. So here, book author equals proceeds. So my XML processor can deal with attributes. It understands them and parses them. All parts of an element are Unicode text, typically UTF-8. UTF-8 is very like ASCII, but not identical. The UTF specs are really interesting and complicated. There's a lot of stuff to consider when you get down to the details. You know, when you start using Sanskrit characters or Chinese ideograms or Arabic curly, swirly stuff, UTF was designed to let you manage all that. So there's a lot of stuff going on. I'm no expert with that, but there's some nice specs. Fortunately, I know of one, and I didn't provide a link to it, but if I think about it, I will. XML names are composed of Unicode characters. Tag names must begin with a letter or underscore. Other tag name characters may contain characters, underscores, digits, hyphens, and periods, very like names in C++ or C#. Same kind of rules. Names may contain neither, they may not contain spaces, and they may not start with a string XML or any case variant of XML. Attribute names must follow the same rules as tag names and are also required to be unique within the tag, which they're embedded. So I can have the attribute name student, and I can only have that student attribute occur once in an element. But it can occur in many elements of my document. It's just that it has to be unique in the one element, and each element must have a unique set of attribute names.
In child elements, so that element can't include that same attribute.
No, they can, because it's a different element. So that's a good question. I see what you mean, but no, it's considered to be a different element. So it has to be, so when I have that opening tag, angle bracket, name, attributes, closing, it's in that opening tag that they have to be unique. Element bodies may contain plain text or markup or both. Markup text is text with embedded markup characters, and they cannot occur in text, in the body text. If they occur, they're going to be processed as if they were markup. So, you know, so how do I describe XML in an XML document? Like a schema. And there's two answers to that. One is I can use a C data section. So angle bracket, explanation part, you know, C data. This dot, dot, dot is what's going in the C data. This is the payload for the C data section. And it ends with bracket, bracket, beta that. I can have any markup characters I want in here. And what that does is it tells a processor, do not interpret this as markup. My XML processor is not smart enough to use C data. I don't think I did. I'm pretty sure that I never got around to doing that. But you may look at this and say, hey, great, I can pass binary data in my XML. Wrong. Because somewhere in the middle of that binary data, there might be exactly the right bytes to look like bracket, bracket, greater than. And then the processor would terminate the C data section and start to go crazy trying to handle all those other binary bits. So what that means is if you want to encode, if you want to pass binary data in XML, you can, but you have to put it in character form. So I can convert it to hex, or I can do a base 64 encoding. And most people use base 64 encoding because it's a little more compact than hexadecimal. And there's I have a little program fragment on the college server that does base 64 encoding. We won't need to do that. Alternately, instead of using a CData section, I can simply, whenever I have an angle bracket I don't want to be interpreted as markup, I just say ampersand LT semicolon. This is escape sequence. Same thing for greater than, same thing for ampersand, same thing for apostrophe, same thing for quote. And if you look at my web pages, you'll see me use those. For example, in the code snaps for template class, I have the angle brackets. The pound includes, I have the angle brackets. They're not being treated as markup for the HTML because I have ampersand less than, ampersand greater than. I wrote a little program called Webifier that processes code, and all it does is it puts a pre-tag, pre-opening tag, pre-closing tag, which means render this with all the spacing the way it's, you see it in the text. Don't change any of the white space, don't flow the white space around. And then inside the body, wherever there's the markup characters, I just change them to their escape sequences. That's what my Webifier does. It lets me put up web pages, code on web pages really easy. XML document, so now we were talking about XML syntax, now we're talking about the document structure. XML document is defined by a standard opening. Now this turns out processing instructions are instructions that have no closing tag. They have exactly the structure. A while back, I went and looked at the standard, and the standard goes to great pains to say the declaration is not a processing instruction. There is no other way you can distinguish it from everything it does and contains is exactly what's allowed in the processing instruction. My own mental model is if it looks like a duck and quacks like a duck, it ought to be a duck. Okay, but the standard didn't agree with me. This is a declaration. So anyway. But I will refer to them as processing instructions. The banner comments don't have any closing. Comment is done this way. I mean, this closes the comment, but as an XML markup, there is no closing tag. And occasionally we'll put in processing instructions that are not to be interpreted as data. They're just instructions to the processor to process it this particular way. So, a well-formed XML document has these rules. There may be only a single root. This applies to both, everything I've said here applies to both XML fragments, well-formed syntax, and documents. They may only have a single root. All tags except for processing instructions must be closed, and you can close them this way, or they can be self-closed, just a tag that's self-closing tag. Okay. In this case, all the information is conveyed by the name of the tag and this attribute. There's a lot of cases where that's all you need. Attribute values must be quoted. XML tags are case sensitive, so that means Jim with a capital J and Jim with a lowercase j are two different tags, meaning two different things. All markup and payload is text, with one exception, CData sections, which we already talked about. And this page talks more about CData, so let's skip it. XML document is well-formed XML if it contains a prologue, optionally links to an XSLT style sheet to turn it into something else. We won't do any of that. An optional reference to a DTT or schema. We won't do any of that. Optional processing instructions. We won't do any of that. Optional comments. You probably ought to. A body with a single root. An optional epilogue consisting of comments and processing instructions. So that's a well-formed XML document. When you persist your database, probably a good idea to include the XML banner, but you're not obligated to. It'll work just fine without, just as a fragment, but it's not a bad idea to include the banner. By banner, I mean this thing, the declaration. So processing instructions has this syntax, question mark, target, attribute value. Boy, that looks like the declaration, doesn't it? Standard says this is not a processing instruction. The standard says the declaration is not. So this is the, this is the declaration right here. So anyway, namespaces, I am not going to talk about. Namespaces, other than the following couple of words. Namespaces are used for the same purpose that namespaces are in code. If I have several teams that are collaborating on a large XML document, this team may define a tag that means one thing, and this team uses the same tag name to mean something else. How do we disambiguate that? We do it with namespaces. Same kind of thing we do with code. The rules are a little more complicated than they are for code, and almost most documents aren't developed by teams. They're developed by one or two people working together. So, if you're interested, if I were needed to use namespaces in my documents, when you step out of here and go to work, you may have to. It would take me about a morning or maybe even all day to get all the rules, to remember all the rules and get them right again up here, okay? Because they're a little complicated. Just here's my example. So here's this is what we looked at, but this completes it. Here's the declaration, here's the comment, and the lecture note. So, and here I have shown the lecture note parse tree without the text nodes and any other decoration, just to keep it simple so you can see the structure. But here's the whole parse tree. This is what my processor builds in virtually any other DOM-based processor. A document, and then these declarations and comments. Here's the lecture note. Here's all these nodes. I've marked these as A if they have an attribute. So that A just means that this has an attribute. That's all it means. Okay. XML can be presented in a bunch of different ways. One way is on a web page. HTML has an XML tag. And what that means is that in between the opening and closing XML tag, I can put XML. That is not rendered by the browser. But I can have JavaScript, a JavaScript function that goes and interprets that, parses that, and does stuff on the XML page based on what's in that XML. Here's a typical scenario. I have a web page that puts out information that contains in one part of it information that changes every day. And I can get that information from a web service. I don't want to re-handcraft that page every single day. So what do? I have XML, and that XML can just be a template. And I have JavaScript that goes and reads the web service, and then fills in the template and renders it, and so you see it. Okay. So now, nobody has to doctor that page every day. It just happens. It's updated. Cool. There's other ways to do it, but that's one way. Now this set of notes begins to talk about XPath and XSLT. We're not going to use those things this semester. You can look at them or not as you choose. What I want to do is run my version of this. So if you go and look at, I'm on the college server, so if you go and look at Project One Help Spring, you'll find XML document. And this is my XML processor. I'm going to run it off my machine, so let me just go. This is an old web page. Did I show you at the beginning of class, I showed you the Office Hours page, didn't I? So, let me just pull up. Now, where I want you to get this, notice I want you to go, Project One Help Spring 18. I guarantee you that this stuff will be the current code. I have an awful time with configuration management. I've been reckless about where I put stuff. I'll put copies of stuff all over the place. And I'll remember to get those two places updated, and I'll forget that those two places aren't updated. And so I'm constantly having students pull down old code and say, hey, what's going on? You know, I fixed a bug, and they report the bug again. So, but if you go to the Project One Help Spring 18, S18, or for Project 2 Help, guaranteed they'll be up to date. I will keep them up to date. I am also putting, I have a bunch of repositories in each class, which I'm going to get rid of. I'm going to move everything to one single repository at the top level, but it's going to take me a while. So until I tell you the repository is now well-formed, guys, until that happens, don't go there. Go to the Project One Help, or follow the links on the web pages. But you know, the best place is to go to the Project One Help. So I don't have that. I forgot to upload that stuff from my to this machine from my work machine. So I don't have that XML document in my Project One Help. So I am going to go to the repository and pull up XML documents. So this is an SU repository CPP. No promises that this will be up to date on the college server. Don't promise that. You know, go to the Project One, Spring, whatever. So I have X document and X element. Let's look at X element. So X element has an abstract XML element base class, and I am using shared pointers. This is provided by, as of C++ 11, a smart pointer provided by the standard library. And that smart pointer, you don't have to call delete on it. When it goes out of scope, it deletes its contents. It's reference counted, that's why it's called a shared pointer. So if I have two shared pointers pointing to the same object, when one goes out of scope, basically this reference count, it decrements the reference count. When this guy goes out of scope, it decrements the reference count. If the reference count goes to 0, the object kills itself. It calls delete on this. So I'm using shared pointers, and I will talk. I owe you a little bit of conversation real soon about two things. To understand this thoroughly, you have to understand shared pointers, and you have to understand lambdas. I also have a very tight agenda here. On Thursday, I'm going to talk about abstract data types, and on Tuesday, I'm going to finish abstract data types. That's the most important lecture, a pair of lectures in the whole course, and it has to happen now. So I can't stop. So as soon as that's done, on Thursday of next week, I will talk about shared pointers, I'll talk about lambdas and functors and all the related stuff, and then we'll go back and look at this example again. I think you could use it without understanding all that mechanism. But you'll notice that there is a abstract element that has an add child, add attribute, remove attribute. You can get the children in a vector of smart pointers. You can get the tag, you can get the value. You can convert that element to a string representation of the element. So it gives you lots of stuff. Now, there is a doc element. This is the guy that sits at the very top. Okay, so he So in this abstract element, notice it's some of these are equal zero. These are pure virtual functions. This says that this class does not provide definitions of these. And as a consequence, the compiler, if you try to create an instance of this, the compilation will fail. It'll say these methods aren't defined. So what you do is you create the child elements, and one of the child elements is a doc element. You don't need to create that because that's just part of my implementation. There is a text element, that's a text node. There is a tagged element, that's all the stuff we're typically used to using, okay? And there is a comment element, and there's a processing instruction element. Those are the elements in my element hierarchy. And almost always you'll just be concerned about text elements and tagged elements. And now let's take a look at the document interface. So let's go to XML document.h. So there is a constructor that takes a pointer. If you give it a pointer to the root of XML, then it makes that document point to that XML root. But by default, there's no pointer, just nothing attached. There is an XML document that you can build from a string. If I have a string representation, like lecture note for that whole thing, you can build it from that string. This delete says you can't make copies of this. Probably makes sense not to copy XML documents. They're probably pretty big things. One of the reasons it is not copyable is that I'm using shared pointers, and you can't copy shared pointers. Assignment is deleted. I have move operations, and starting on Thursday and continuing on Tuesday, it'll be really clear what copy and move operations and assignments are all about. Okay, so just bear with me. That's coming next in 2 days. So I can get the doc element. I can get to that very top document if I want. Okay, to poke at his children and look at his children and stuff like that. I can get the XML root, that first thing that he holds. Okay. Most of these you don't really need to, you probably won't be using. Now I can make queries. So element gets the first child. Elements so here I have a collection that's held internally called found as a result of queries. So when I call element, found 0 contains the first element with a tag, with that tag name. When I call elements, found contains all the children of the first element with that tag. So elements are children. When I call that, that's just stored in found, and I don't see anything until I access found. That's the quirk of my design. Descendants, this is what you'll use most. So I can give a tag name if I want to, and this will, if I give it a tag name, it goes to that tag name and it finds it includes, if my memory serves me right, it includes that tag, all his children, all his grandchildren, all his great-grandchildren, all his all the way down. So you get a collection of all those nodes. Here's the find function that lets you go find a particular tag. You can ask how many elements do you have in the XML document. This is a really node count. I can take this document. If I modify the document, now I can generate a string representation of that document, and I can save it to a file. Okay, and here, depth first search. So here's what's going on here, and this is why, So let's look at this. Let me talk to you about this. We go until, I have 7 more minutes, is that right? Oh boy. So notice this function depth first search walk. It has a sub-template, okay? Call object, and what this is doing is doing a depth first search walk down the XML parse tree, applying to each element call object. Call object is a callable object. It could be a function pointer, so it just calls that function on each element that it finds. But it could be a functor. Functor is a class that implements operator paren. That's the code that's executed. And it has data members. That's data that's used in the execution of that function. And so if I pass it a functor can accumulate as you walk down the tree. It can accumulate information that you're gathering. And then when it's all done walking, you can go to that functor and say, give me that information. So it's a very general, wide open, and typically we'll pass lambdas into this call object. And again, I owe you a conversation real soon about functors and lambdas. Okay. All right, so I'm going to stop here and just show you a tiny bit about functors and lambdas. I will Friday morning, in the help session Friday morning, I will run this for you. We'll talk about it a little more. My goal for Friday morning is to do 2 things. To show you this XML processor, run a little bit. I have simpler XML reader, XML writer that don't build the DOM. They just do string, they do a string walk, but they're not nearly as powerful. They don't know what an attribute is. So if you have any attributes you don't use, it won't work. So, but if you keep things really simple, you can use the XML reader and writer if you want, but XML document is the preferred way. I will run this for you in the help session, and then I'll talk a little bit about query stuff. Again, I'm not going to paint yellow footsteps, each footstep on the rug to get you to a full query, but I want to point the direction to you. If you come to the help session, there's going to be 2 waves, one at 9 o'clock, one at 10:30. Do not bring chairs in from other rooms so that you can sit in that first session. People did that last week, and Dr. Gershoy had a meeting in 287, and he walked in from the meeting, there weren't any chairs. He had to cancel his meeting. Do not. He was very kind about that, but if it was me, I would have been grumbling, what the heck is the matter, So, don't do that. I promise you, I will be here at 10:30. I'll kick everybody out at 10:30 and welcome you in. So, if you come, there isn't an existing chair already here. One of those pink chairs. We'll do a survey. If it ain't pink, it goes out. Okay? So if you're not sitting in a pink chair, you know, you'll be asked to leave, but you come back at 10:30 and there'll be plenty of pink chairs for you to sit in. So let me quickly, you owe me, guys, don't get restless. Don't get restless. You owe me 5 more minutes. I will run this for you Friday. We'll talk about it a little bit. But what I want to do is do this. If you go up to the notes section, you'll find course summary. And let's expand C++ language. And let's go down. Here's functors. Here's a quick description of what a functor is. So a functor is a class that implements operator paren. And it can store data. And I give it the data perhaps in a constructor call. And what happens is, here I'm declaring, this is class a functor, I've declared an instance of a functor. Now, this is nothing special about this name. This could have been foobar. So here, I've declared an instance of my functor. I declared some y to pass to it. Okay, so notice that operator paren accepts a y. So I declared an instance of y, and now I said func y. It looks like a function call. That's why we call it a functor. The code that's executed when I call this like a function is all the code implemented by operator paren. But it may use any functions like x that it's that it got in a constructor call or some other member function call to participate in that code evaluation. Okay. So I can pass it. So I could pass a functor. I could design a functor that does something interesting on all the nodes of that parse tree into depth first search walk because it accepts a callable object. And a functor is a callable object because it implements operator paren. Now, a lambda is a shorthand way of defining a functor. Here is a lambda. It starts here and goes to here. That's a lambda. Now, my comment runs off the screen, but the compiler, when the compiler sees a bracket and an empty space before it, it says, oh, this isn't an indexer, this is a lambda. If I have equals in here, it says any values that so what happens is this lambda, notice this lambda uses message. Message is defined in its local scope. It's just, it was the calling argument in that function, make lambda. So what's happening is the compiler is building a functor whose operator paren implements this code. And it has member data that was used here. So message becomes a piece of member data in that functor, and operator paren implements that code. So it's just a shorthand way of writing a functor. But it is real quick, done locally. And so I can, the first search walk, define a little functor, ready my call, well, you know, there we go. We use functors we use lambdas all the time. They're really useful. You'll see them a lot in my code. So if you look at the main of my XML document, where I'm trying to illustrate how you use it, you'll see me using functors. I have test this, test this, test this, test this, and those test functions are using functors. I'll talk more, see more about functors. We'll come back to it. Try to get you really comfortable with it because it's really powerful. You're going to use it a lot. Okay, I'm done. You can get up and leave.